Good morning, children. Welcome to maths class. So, in maths, we have completed with block 20, isn't it, children? So, let's start with block 21, which is like fractions, adding and subtracting. Okay, so in this, our first topic is fractions that add to one whole. Okay, one whole. Okay, children. So before solving the problems in this, let's learn about the like fractions and unlike fractions. Okay, our block is about like fractions, adding and subtracting, isn't it? So first we have to know what is a like and what is an unlike fraction, isn't it, children? So let's learn the definitions. The first one is unlike fractions. So unlike fractions are the fractions which have different denominators. Okay, that means we are going to compare the two or three fractions, two or more fractions, we can say. If those fractions have different denominators, then those fractions are called as unlike fractions. Okay, for example, 1 by 7, 3 by 8. So in the first fraction you have 7 as denominator, and in the second fraction you have 8 as denominator. That means these two numbers are different. The denominators are different, isn't it? So these two fractions are called unlike fractions. Okay, children, here I have given only two. We have compared only two, isn't it? But we can compare any number of fractions and we can say whether they are unlike fractions or like fractions. Okay, so the fractions which have different denominators are called as unlike fractions. Okay, now coming to like fractions. Like fractions are the fractions which have same denominator. Okay, so if the fractions have same denominator, then those fractions are called like fractions. Okay, example, 2 by 9, 3 by 9. So here both have 9 as denominator, so these two fractions are like fractions. Okay, and when we are adding like fractions or subtracting like fractions, you can directly do with the numerators because denominators are same, isn't it? That means here you can add 2 by 9 and 3 by 9. Denominator is same, so denominator will be 9 as it is. So numerators 2 plus 3, 5. 5 by 9. That means if you add 2 by 9 and 3 by 9, you will get the answer as 5 by 9. And if you subtract 3 by 9 minus 2 by 9, that becomes 3 minus 2 by 9, which is 1 by 9. Okay, so what I am telling is, for like fractions, when the denominators are same, you can simply add the numerators if you want to do the addition, and you can subtract the numerators when we have to do the subtraction. Okay, children, you understood? So write these two definitions in your classwork, okay, along with the examples. Okay, now let's see the sums related to this like fractions. Okay, so write the fractions as sum of equal fractions in two ways. Okay, so let's see the sums. So you have to write the sum of equal fractions, that means sum of like fractions, because if it is unlike fractions we can't do it, isn't it, children? We can't directly add the numerator, so we have to write the like fractions, but they should be equal. Sum of equal fractions they has, isn't it? So in that way we need to write. So let's see the first one. 6 by 6. Children, I have told you in the previous blog that 6 by 6, 3 by 3, 2 by 2, 1 by 1, 8 by 8, 5 by 5, all these are one whole, I said, isn't it? So here they have given a whole 1, which is 6 by 6. That means for a figure it is divided into 6 equal parts and all parts are colored or shaded, isn't it? So that's make one whole. All colors are, all parts are shaded. Yes, so for this fraction we have to write the sum. Sum here means addition, children. Sum of equal fractions. Okay, they did not say two fractions or three fractions or four fractions, but the fractions should be equal. Okay, so let's draw the shape so that we can understand easily. So I have drawn a circle and I made into 6 equal parts and I have colored it also. Okay, here children, in the question they did not ask us to draw. Okay, so in the notebook we need not to draw. Okay, only for explanation I have taken this picture. Okay, in the notebook don't draw it, because in the question they did not ask us to draw. Okay, now 6 by 6. So here it is a circle which is divided into 6 equal parts, and all parts are shaded, colored, isn't it? So if you see children, sum means addition, that means you have to do the plus. So equal fractions, if you take one part, so the other parts will be 5. That means 1 by 5 and 1 by 6 and 5 by 6 you will get. These are not equal fractions, isn't it children? But we have to do equal fractions. Yes. Now let's go with 2. So 2 by 6 plus how many are remaining? 1, 2, 3, 4. 4 by 6. So this is also not equal fractions. This is 2 parts. This is 4 parts that are not equal parts, isn't it? Now let's go with the 3. So 3, 1, 2, 3 here you have, and 3, 1, 2, 3. So here you are getting 3 by, this is 3 by 6 and this will be a 3 by 6. Both are equal, no? Both are same. So you can write 3 by 6 and 3 by 6. That is 6 by 6 will be equal to 3 by 6 plus 3 by 6. Isn't it children? 3 by 6 plus 3 by 6. Okay. So we have written one way of equal fractions, isn't it? So but they asked two ways, isn't it? So let's see one more. So 3 we have finished. Let's see with 4. So 1, 2, 3, 4. 4 by 6. And what is left of? 2 by 6. That means they are not equal, isn't it? So leave it. Now go with 5. 1, 2, 3, 4, 5. 5 by 6 and 1 by 6. That is also not equal. But if you take each part children, 1 by 6 plus 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 1 by 6. So all are equal. 1 by 6 is only, isn't it? So we are writing addition to 1 by 6 plus 1 by 6 plus 1 by 6. So we are writing equal fractions. All are 1 by 6 only, isn't it? Here we have 3 by 6 and 3 by 6. Here next you can write 1 by 6 plus 1 by 6 plus 1 by 6 6 times. That will be equal to 6 by 6, isn't it children? So we can simply take each part as 1 and we can do the addition, isn't it? So 6 by 6 will be equal to 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. 4 parts we have finished, no? So here 1 plus 1 2, 2 plus 2, 2 plus 1 3, 3 plus 1 4. So 4 we have finished. More 2 parts are there. So you will add 2 more. 1 by 6 plus 1 by 6. Okay, so we have written sum of equal fractions in two ways for the given fraction. Okay, given whole we can say 6 by 6, no? One whole it is. Yes, so in this way you need to write the sum of equal fractions for the given fraction as whole. Okay, so let's see another one. So 4 by 4. So that means you have to take a figure and make it into 4 equal parts, and we need to write the sum as before. Okay, so I have taken a square which I have divided into 4 parts. Okay, now which represents 4 by 4, one whole it is, isn't it? That means all the parts are colored, isn't it? So one whole. So 4 by 4, if you take children, so it becomes 1 by 4 and 3 by 4. 1 by 4 plus 3 by 4, which are not equal, isn't it? Now here 2 by 4, if you take these 2 by 4 and left out is 2 by 4, isn't it? So you can write 4 by 4 as 2 by 4 plus 2 by 4. Okay, so here denominators are equal, so 2 plus 2 will be 4, which is equal to 4, isn't it children? So in that way also we can write. And if you take 3 parts, then it becomes 1 by 4, so that you can't write. But if you take single parts like 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, that will be easy, isn't it children? So and also they are equal fractions. 1 by 4, 1 by 4, 1 by 4, 1 by 4, they are equal fractions, and we are doing the addition. So you can write 4 by 4 as 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, which is nothing but all the denominators are same, so you can add the numerators, that is 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, so which is 4. Okay children, so in this way you need to write the sum of equal fractions in two ways for the given fraction. Okay, so in this way there are few more sums in your daily schedule children. Please copy it down in your class workbook. Okay, coming to your next question, what fraction will you add to get one whole? So children, here they have given 2 by 12. So there is a fraction which is 2 by 12 and you have to make it one whole. So for one whole, the fraction will be, for the given fraction, 2 by 12 means one whole fraction will be 12 by 12. Isn't it children? That means here for this 12 by 12 is one whole. For the question, according to the question, it will be children. Okay, if it is 12 by 20, then the whole will be 20 by 20, isn't it? So here the whole is 12 by 12 is your whole. Now what he is asking, what should be added to 2 by 12 to get 12 by 12? Okay, that means 2 by 12 plus something, like we will make it a dash. A dash is equal to 12 by 12. 12 by 12. Okay, now denominators are same, no children, so it is a like fraction, so you can directly subtract or add, isn't it? So to get 12, what we have to do, like normal numbers, what we'll do, we'll just do it 12 minus 2. Okay, 12 minus 2 will give us 10, so the fraction will be 10 by 12. 12 denominator will be same, the numerator will be 12 minus 2. 12 minus 2 becomes 10, isn't it? So you will write 10. So what should be added? 10 by 12 should be added to the fraction 2 by 12 to get one whole. So that's what you will write. Therefore 10 by 12 should be added to 2 by 12 to make one whole. Okay children, so in this way also they can ask question, but they might be giving you a different fraction. For example, 3 by 39. So 39 by 39 becomes your whole, isn't it? Then 39 minus 3, whatever numerator they have given. So in that way you need to solve the sum. Okay, next one. So GR divides her cheesecake into equal parts. Fill in the table. That means she has a cheesecake and she has divided into 6 equal parts. Here they have given parts which is 6, isn't it? So 6 equal parts. And we have to see what will be the fraction if she eats the same cheesecake 6 parts in 6 days, 3 days and 2 days. Okay, so if it is 6 days, that means 6 parts and 6 days. That means she's eating per day how much? 1 by 6. For one part only, isn't it? In 6 parts, she is eating only one part, which becomes the fraction as 1 by 6. Isn't it, children? And how can we show the whole part fraction to show the whole part, whole cake? That is 1 by 6 plus 1 by 6. 2 days we finished. Then the third day 1 by 6. And the fourth day 1 by 6, and the fifth day 1 by 6, and the sixth day 1 by 6. Now if you add the fractions, so these, if you see, these are like fractions, isn't it children? They all have the denominator 6. So if you directly add the numerators, then that becomes 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6. So it is 6 by 6, which is nothing but our whole fraction of the cake. Okay, next. So if the same 6 parts she have to eat in 3 days, so each day she has to eat 2 parts, no children? 2 parts first day, 2 parts second day, which becomes 4 parts, and on third day she eats 2 parts. That becomes 4 plus 2 6. That means if she has to complete that 6 parts of the cheesecake in 3 days, that means she has to eat 2 parts each day. That means the fractions become 2 by 6, isn't it? Yes. So the numerator will be the number of parts she is eating and the denominator will be the total number of parts, which is 6. 2 by 6, isn't it? Now we have to write the this fraction to show the whole cake, that is 2 by 6 plus 2 by 6. This is becomes the second day, and on the third day again 2 by 6. Now the denominators are same, isn't it? So you can directly add the numerators, that is 2 plus 2 4, 4 plus 2 6. So 6 by 6 is your whole cake fraction. Okay, now the same parts, 6 parts she have to complete in how many days here? 2 days. So if she has to complete in 2 days, how many parts she has to eat? 6 parts. Each day she has to eat 3 parts, isn't it, children? So the fraction becomes 3 by 6. 3 by 6 one day, and the other day 3 by remaining 3 by 6. 3 parts. That becomes 3 by 6. So the fraction will be 3 by 6, and to show whole cake, so 3 by 6 plus 3 by 6, which is 6 by 6. Okay, so in that way you have to do the sums, children. Do it in your classwork. Coming to your homework, complete the volume book, children. Volume book 3, page number 25, S1, fractions that add to one whole. Okay, so in the next class we will learn the next topic, children. See you in the next class. Bye.